Hello all and welcome back. So in this video, I want to discuss another approach to check if our given tree is a BST or not. So we have already done the same using the min, max and is BST where we were expecting three values and we were able to optimize the same to an ON approach as well. Now in this particular solution, I actually want to show you that there is another approach also of doing the same kind of a question, just if we think in a different direction altogether. Okay. So in the last video, we saw the question which was based on range, printing the elements on the range, right? So the idea is the same only. Let us see for this particular, let's say binary tree, BST, binary tree. We will have to take binary tree. We cannot assume that it's going to be a BST. Okay. So let me make it complete. Yeah. So first, let us think that what can be the values which my root can overall take. So this we know is the root, right? I believe root can take the value from minus infinity to plus infinity, right? For root, there is no overall concern or overall limit on which value root can take. It can be any value. But then root decides that what exactly can be the other value which other nodes can take, right? So in this approach, instead of thinking from bottom up, so earlier what we were doing, we used to make the call and then ask each and every node their status along with their min and max. Here we are following a overall top to bottom approach where I will be saying that hey, I am sending my work, I am doing my work. Okay. I am saying that you can be from this value to this value. Now please handle the same. Okay. So we are not waiting or we are not doing it from bottom to up where I'm waiting that okay, all these values or the results are going to come up. Now, if let's say in this particular case, let's say my root is 50. Okay. Then I know what's going to happen for this particular left subtree. It can have values from minus infinity to 49, right? It cannot have values which is greater than 49. I hope that is clear. Because if it will have, then it's going to be a problem. It's actually will not be a BST. Okay. In a similar manner, let's say it's 35 here. Great. Now, if it's 35 and say we have a node here as well, we have a node here, then this node, particularly this node, it can have values from 35 to 36, sorry, to 49. So we are saying that duplicates will not be there. If there are duplicates, we can handle it on one side. Let's say on the right side, duplicates are allowed. But for the current discussion, let us assume that duplicates will not be there. So what I'm doing effectively, I am reducing or rather redefining the range in which my nodes can take the value, can take a value. So all I'm doing is going from the top. I'm just making sure that I'm reducing the overall limit which each node have with respect to value. And by doing the same, what can I achieve is that I can get that limit where this node should have the data, right? In which limit this node should have the data. If it is not the case, if that fails, then we can just easily return false. Okay. So great everyone, let us now try to code this as well. It's a really smart technique just to show you that, always try to think in multiple scenarios at how else can we also solve this problem. So let us code this in check BST only. And I hope you have done this check BST better yourself, right? So I have also shared the solution, but pretty much sure that you would have been able to run the same. Okay, great. So let us see this one everyone now. What I have to do, check BST, right? Limit. So I'm just writing it like this, limit. Based on limit, we are doing this thing. I will be getting a node, or let's say root. I will be getting a min. So we are saying it mini and maxi. The reason is that max and min are already functions which are defined, right? So we want to make sure that we are able to use them. Great. If node is none, I can directly say that it's true, right? If my node is none, then for sure I can say directly that the tree is a BST. Great. Let us code it here. Next, if node dot data, okay, if the data of node is less than whatever you are giving me as mini, and or node dot data is greater than max, then I should return false, right? If any, okay, we have taken root, so let me take and talk in terms of root only. Great. So all I'm saying right now is that, hey, this limit which you are giving, if I'm greater than this maximum or if I'm lower than this minimum, okay, then it's a problem. Please return false. I should not have that thing. For readability, let me make it minimum and maximum. And once this is done, you just have to call, or let's say answer left. We can write all of this in a single line as well, but let me just write it in a multiple lines so that it is clear. Root dot left, I'm calling on left. On the left, minimum should not be changed, right? So when I'm saying minus infinity, it can take the value from minus infinity. That is not my problem. I just want that it should not be bigger than me. So if I'm 50, you can just be till 49. Okay, great. So what we can do here, minimum will remain the same, but maximum I have a value. So you just have to remain in this particular value. Similarly for right, it's the opposite. So check BST limit, root dot right, and the minimum will change. So when I will call here now, each and everything should be greater than 50. Like I would say that it should be 51, and maximum you can take any value. So on the same note, it will be root dot data, okay, plus 1 and maximum as it is. Maximum. Okay, done some mistake. Should be fine. Great. Now it should be fine and root. Okay. So yeah, this, once I have the answer, I can just return answer left and answer right. So I've checked for myself. If I was not, then I was returning false. Else, we will let recursion do the work. Okay. So great, everyone. Let us just quickly check it. We know that this one is a BST, so it should be true. This one is not a BST, so it should be false, right? Okay, which error? 1 second. Two positional, we are missing it. Yeah, our bad. So we have not sent the limits. For the limits, what we have to send? Float. For the minimum, the value can be infinity, right? And for the maximum, for the minimum value should be minus infinity. 1 second, yeah, minus infinity. So we are taking minimum first, right? So minimum is first, and then we are taking maximum. Okay, everyone. So just let me clear and zoom out. Yeah, now it should be readable. So pay attention. What we are doing, we are sending that minimum. Okay. Initially, it's minus infinity to plus infinity, right? So on that note, we can just do and send the values as this. And we can just copy this whole and paste it here. Great. So let us run this now, everyone. Okay, where else are we missing? Line 67. Okay, print check BST limit. Are we okay? We are closing the brackets earlier, so now it's fine. Okay, check BST and one more bracket. And one more bracket. Great. So it's the bracket of print, right? This is the magenta one is for the function, and this blue one is for this float. Okay. And we are getting an answer. So first one it's saying it's true. Second one it's saying it's false. Because based on this particular, so let us understand with this example. For this 40, it would have said minus infinity to 39. Similarly, here it would have said 21 to 39. In this way, we are making sure that the limits in which the node should be there, we are sending from top only. Okay. The answer for which it is false, it is 5, 10, 15. So let's see why it will be false here. 5, 10, and 15. So here I would have said minus infinity to infinity. I would have said minus infinity and maximum 4 here, right? But this is greater than 4. So that's why we are getting the answer as false. Okay, everyone. So I hope this approach is also clear. Just another way of doing this particular question, thinking from the top rather than asking first from my notes. Okay, so we know the properties, we know some limits, restriction. We are just using that restriction overall to get to our answer. So yeah, do practice it once and try to dry run it as well.